Assalamualaikum and very good morning. So today we're going to look on the collision detection in the computer graphics environment. Okay, so let's move on. So today is Monday, 6 April 2020. Okay, move on. Okay, this is some sort of simulation that, or actually a games that use collision detection, such as Flight Simulator, the Cool Flight Simulator, Gran Turismo, and also Need for Speed. Of course, in car games environment, a lot of collision detection need to be obtained and simulate in the game itself. Okay, and then there's also the physics puzzle games such as Bridge Builder, where you need to stack up upon each block of the bridge, okay, in order to create the very stable bridge, and in order to let the vehicle pass on. So every time you complete the level, you move on into the another complex level. Okay, and then the cradle physics, where you need to draw the object, okay, in order to make it the mechanical stuff work over here. Okay, so sorry, this is slide. Okay, and then this is a fantastic contraption. Okay, where actually there is you need to also stack in the stuff. Okay, and then the incredible machine. So there's a lot of games. So previously, previous slide, this is the example of the game: Gran Turismo, Need for Speed, Flight Simulator, and so on. Okay, and then another type of sandbox game. Sandbox game is where the game itself contains a lot of stuff. Okay, for example, GTA 5. So where mix many types of genre in that game: action, adventure, first person view, and so on. Okay, first person shooter game, and so on. Okay, and then also the sport game, one of the oldest game, and then Little Big Planet. Okay, so this is just an example of where actually collision apply in the computer graphics world. Okay, so actually what is a collision? From the figure itself, you can see that we need to check some stuff involve the object itself. Okay, so actually the collision detection is the computational problem of detecting the intersection of two or more objects. You must have two or more objects. Okay, so we need to detect between each other whether the object is collide or not. For example, this is we have a two box here, or two square. So this is one axis overlap, and then you need to check whether there's two axis overlap, but it's still not been we cannot determine yet whether it's collide or not, since we might this box, this square might be their bonding volume. We can see another topic after this. What is a bonding volume? Okay, why we need a collision detection? Obviously in game. So that's what in games we need to have a lot of collision. Okay, so by the collision, of course, we need to detect between the bullets hit the object, they hit the enemy, and so on. So a lot of collision detection stuff is happening in that game. And then also in simulation and animation, where we can just apply the collision detection algorithm on the application itself. Okay, so what is the requirement? Okay, of course, the first one is two or more objects. The second one is there's a mathematical equation where we need to check, okay, between each object, and then we need to have an algorithm to check. Okay, so that mathematical equation must be inside the algorithm, and then continuously check for each object that exists. Okay, so somehow the simulation or the application that you have created, you must put a code where the algorithm will continuously detect for the collision for each object. For example, if there is a lot of objects, we need to detect. Okay, it says something like we ask the question: do this object collide, or did this building collide with another object? So each of the object has their own mechanism. Okay, so you can put one general collision detection algorithm to check for the collision, but the object itself have all the object inside all the object inside the virtual environment has some sort of like a sensor. They will pass the information to the collision detection algorithm to check. Okay, for example, this is the first square box that you use to check for the collision, and then there's a subsequent. For example, the second level of regression where there's a mini square box that actually have this stuff. Okay, so this is the first object, and then this is second. This is the first box. Okay, and then once it's done check for the primary check, this first step. For example, you are using the for loop. Is this the outer boundary is collide? Yes. If yes, check it again with the small box 1 and small box 2. Is this collide with this second with this object? Okay. So of course, by looking at the figure itself right now, it's not collide. So we need to have some sort of like a second phase of the collision detection algorithm. Okay, let's move on. So where is the collision detection is actually located? So actually collision detection is located inside an animation, which is also part of the graphic system, but in computer graphics. So it has shaping, rendering, imaging, animation, and graphic system. Okay, so this is where the collision detection is located. It has broad face collision detection, and it also has a narrow face collision detection. Because we don't want to look upon the detail of this. We just look on the surface of the collision detection algorithm. Okay, the stage is broad face first, and then move on to the narrow face, and then of course the collision response. When we detect what happened next, of course we need to have some sort of like response, like the objects is somehow become dent, or maybe there's some destruction happening. Okay, so the building collapse, or the impact after the collision happens. Okay, so this is broad face. We use our boundary volume or boundary volume hierarchies, where we split the object into the smaller box. Okay, just what I have explained previously. And then there is also narrow face, where we need to check down further to the vertex, edge, and faces. Okay, slower response. This one is most likely for the simulation. Okay, where we use supercomputer, the computer that has very high-end graphic system that has capability to concentrate on high accuracy simulation, such as medical simulation, realistic AR application, and so on. Okay, this mostly profit is just for games. Okay, because in games we just need to have fun. Okay, we don't need to have some sort of like very critical simulation check between objects. Okay, this is example. What happen if we check for the object vertex, edges, and surface for the collision? Okay, for example, we just test the object vertex. Vertex is point A1, A2, A3, B1, B2, B3, and also the edge. The edge is the edge of A1 between A2, the edge of A1 between A3, the edge of A2 between A3. So same thing with the B. So this is how the total of testing we need to be done. This is what happen if we don't use the boundary volume. So a lot of testing. So it's total of 27 testing up there, but it's probably took less than the 1 microsecond. What if we have a lot of triangle here? Okay, more than 60,000 triangles and so on, millions of triangles. What happens? Consume time. So in games we don't need to have some sort of like a narrow face collision detection where we need to check down further into the vertex, edges, and so on. But we can check for the broad face first, either it's collide or not. If the broad face is until certain level is not passed, so meaning that there is no collision. Otherwise we need to check is further. That's important for the medical simulation. For the games we might check until second or third level. We don't need such a very accurate collision in game. So that's the key point between games and simulation, and also for the animation. So this is two common ways of to detect collision in broad base: bounding volume or space partitioning. So this bounding volume, where the object itself is bound with the box, or another type of bounding volume. This is another few types of bounding volume. The very common one, ABB, okay, OBB, okay, sphere, convex hull is which is follow the object itself, six stop and so on. Okay, you guys, I will give you guys an assignment to do, which is 4 of you. So I will randomly assign. So which one of you guys will get OBB, which one of you guys will get sphere and so on. Okay, so you need to have to send this assignment by using your PowerPoint to explain what is ABB, what is OBB, what is sphere, what is maybe convex hull, how we going to use them to check between objects. Okay, this is an example where for example we have a bunny here, okay, have multiple bounding volume, which is for the object. Okay, actually this is called bounding volume hierarchy, where the bounding volume is not, we not just have one, but a lot of for many refined level. For example, we might bound the first level with the very big bounding volume, and then the second one just a smaller one bounding volume, and then it becomes smaller and smaller in order to increase a little bit the accuracy, but not too much. For game it's not too much, maybe until this level, maybe this one maybe around third or fourth level. But for the very accurate simulation versus medical simulation, we need to have maybe until the vertex testing between edges and so on. Okay, so this is another type of bounding volume: sphere, ellipsoid. Okay, this one is aligned bounding box, ABB. I just show you just now. Oriented bounding box, convex hull, this KDOPS, segregation, and a lot of algorithms there, sweep volumes and so on. This is very complicated algorithms of bounding volume that the researcher has been introduced to cope with the simulation problems in collision detection. What about space partitioning, or we can call it as a space subdivision? So it consists of the space itself. Okay, for example, we have the very big bounding volume, very big space. So this is uniform subdivision, properly adjusted in symmetrical. And then we have the quad tree, we have KD tree, we have BSP tree. So this also I will give it to you guys to assignment to do just some information using Microsoft PowerPoint to present how they work, how they are going to be implemented in the virtual environment. Okay, this is example. For example, we have a surface of A, and then it's subdivided into B and C, and then B is subdivided into E and D, and E and D is subdivided into, for example, this one is G, H, and so on. So it looks like a tree. Okay, it's like a tree. Okay, what is the best choice? So it depends on the application. Either it's try and error, a gut feeling, or okay, I think I just want to put ABB there. So no one will actually know which one is the best. But you can try put ABB, sphere, KDOPS, and test it all the way and choose the best one. Okay, you just carefully analyze based on the cost function. Okay, you can use that. But for in games, they just use maybe either ABB, OBB, or sphere. They don't need to use some sort of analyze based on the cost function and so on. It's just a game, just to make it the game just for fun. But for simulation, maybe you need to think about carefully analyze based on the cost function. Cost function is some sort of like a formula to calculate how many computational costs. Okay, how many times that it requires in order to check between the points and so on. The factors, of course, you need to consider complexity of the implementation. How complex is it? For the games, we don't need to have some sort of complex algorithm. Storage overhead. Okay, you need to check how many objects in the simulation. 10,000 objects, millions of objects. Okay, and then computational overhead. Your cost of the CPU. Can it handle it? Okay, the type of geometry, static or dynamic. Because in collision detection, for the object itself, we have rigid bodies and we have deformable bodies. Deformable bodies is such as like a fluid base, water, balloon, clothes that actually don't have their type of body to become rigid. Okay. So the few techniques for the collision detection, there's a lot of techniques. This is for just for your knowledge. Okay, for example, we have eye collide here, especially for the multi-body collision detection. Okay, and then you can see that there's a lot of some methodology going here, showing the multi-body pairs, and then check for overlapping pairs, and then check there's some module pairwise exact collision detection, and then check again for the colliding pairs, analyze and respond, and then simulate. And then another algorithm, Swift algorithm. Okay, so you use the Dawkins Kilpatrick hierarchy construction. Okay, so you can see that it some sort like it try to bound based on the vertex itself. So we try to remove as much as possible the vertex. So this is, and then we have V collide. I think it's some sort of similar, just like the eye collide. Okay, but this is V collide. Okay, and then we have a rapid algorithm. Okay, so this is rapid algorithm that involve exact collision detection, which is this one is more on narrow phase. Okay. So there's a lot of calculation of going over here. Okay, this is physics engine. So open enemy engine. Okay, so this is free. So, and then also we have a bullet. It's also free, open source. Okay, it support continuous collision detection. Okay, what is the continuous collision detection? Actually, we have two types of collision detection, which is discrete and continuous. For the discrete, actually we check based on time. For example, every 5 milliseconds we check for the collision, so you don't need to check in between that. Okay, after 5 seconds check, after 5 seconds checks, or after 5 milliseconds. Okay, but for the continuous collision detection, every movement of the object will be checked. Okay, so it's quite a lot of computational cost. This is good for the simulation, but it's not good for the games. Game use discrete. Okay, you can Google on the internet about what is a continuous collision detection and what is discrete. Another physics engine to resist. Okay, and then also physics X. Okay, I think right now has been bought by the Nvidia. Okay, it's included inside. And then Havox, one of the commercial standard game physics engine. You can download it and test it. I don't know whether it is free or not. You can check it on the internet. So that's the end for the collision detection. Just for the information of you guys, what is the collision is all about. Okay, so the idea of the collision is actually to give the response what happened if the objects collide. So everything in the world, in real world, we have colliding stuff. We stack the object between each other. We stack a book. We stack a food on the table. Okay, and then so on. Okay. But also happening in virtual environment world, we need to mimic the what happening in real world. Okay, so we need to put the collision detection algorithm. So when the object is stacked upon each other, we need to check and then give a response. So the response is the object will not be penetrate between the object, so it will stay there. Okay, for example, maybe the car stay on the road, it's not going downward to the down on the earth, so on. Okay, so that's it for today. So I don't know whether we're going to have some sort of like question and answer session based on the internet connectivity. It depends. So otherwise, I think we will handle some sort of like face to face, just for 30 minutes. I think maybe using Zoom or maybe using a Facebook Live. Okay, I will announce it maybe by this week. Sorry for the some sort of like I switch to the mode. I don't know whether what is the time, but I think we will discuss on the WhatsApp group what is the best time for us to have some sort of like live session, either using Facebook, okay, and so on. So you can actually can ask few things and I will try to answer it, okay, as much as possible. And then we can discuss what your anything that is not related to photography is also we can discuss, just to have some sort of like chit chat between you guys. So that's it for today, and hopefully you guys love my explanation and so on. So thank you, bye.